Hi, Professor Mechoulam. It's an honor and pleasure to finally meet you in person.
You're welcome.
You might not know this, but you are actually already part of our YouTube channel.
We filmed the episode about the movie called Scientist. So it's one of the most watched episodes so far, and our viewers really wanted us to do an in-person interview with you. Okay, question number one. So it's 1960s, and you are a young chemist. Why did you choose to put all your efforts and passion on cannabis research?
Well, I'm a chemist, and my specialty, I'm mostly interested in the chemistry and pharmacology of natural products. And I tried working on several types of natural products, on steroids and triterpenes. Actually, my PhD thesis was on steroids, and quite a few other compounds. And I was quite surprised reading that cannabis, hashish, the chemistry was not well known. Now, that was strange, because the chemistry and pharmacology of opiates, morphine, heroin, was pretty well known. The chemistry of cocaine, pharmacology of cocaine was pretty well known. Why not cannabis? Cannabidiol compound had been isolated, which is not one of the compounds that causes the cannabis effects, but it is of major interest. But its structure was not known. And the same was, THC had never been isolated in pure form. And of course, its structure was unknown. And I was lucky to be able to obtain cannabis, illicit cannabis from the police. I used to go there every couple of months and drink a cup of coffee with the person there and get a few kilograms of hashish smuggled from southern Lebanon, where it was grown. And we worked on that hashish for a few years.
Professor, one of our most popular episodes, as we mentioned, was on the documentary The Scientist. In the documentary, you described how a THC pie was made and a group of your colleagues tried it as an experiment. And our viewers and ourselves, of course, are just wondering, because everyone wants to know, did you partake in the experiment as well, or you were just recording and taking notes?
This is one of those funny, unorthodox questions.
Well, when we isolated THC in pure form and we tested it in animals, and it was active, but there is a minor difference between a mouse and a human, and we wanted to know whether we're mice or we act like mice. So we had a group of my friends. We were about 10 friends together in the early 60s. And once we had isolated THC, we decided to try it. We gave 10 milligrams of THC, which is a little bit too much. We didn't know that, grams of THC to half of the friends there, and half of them didn't. I was in the group that didn't get, but my wife got it. Each one of those friends that got it reacted a little bit differently. And we know, of course, that cannabis does not act exactly the same in every person. It depends on the personality, it depends on the reaction, depends on knowledge, who knows what. Anyway, my wife just sat there in a chair and is kind of dreaming. Another person said, nothing happens to me, but he spoke without a break for about 2 hours. And so there were about 3 or 4 that got it, and they were okay, except for one person who felt that she's losing her independence and got afraid, if you wish. I don't think I can say anything else about it. She was, we had a psychiatrist with us, one of our friends, and she spoke to her, and then she relaxed, and that was it. So we realized that THC is a psychoactive compound, and that was it.
The endocannabinoid system is a truly revolutionary discovery that opens up an incredible perspectives in the treatment of various diseases. How much progress have we made since the 1990s when you discovered it?
We learned a lot about a lot about what they do in different animals, how they do whatever they do and so on. One thing that was not well known was mechanism. How does THC act? I mean, what is the mechanism of that? And there were a few mistakes in the literature which probably caused this lack of knowledge. But in any way, in the 1980s, Alan Howlett, a young pharmacologist in the US, found that there is a receptor, a cannabinoid receptor number 1. Now, we don't have in our brain receptors because there is a plant out there. Doesn't make sense. We should, if that's the case, we'll have millions of receptors. We have receptors because our body makes compounds that act on the receptor, whether they stimulate it, whether they depress it. But anyway, the receptor is a major part of the mechanism. So we went ahead looking for compounds that act on the receptor. And we were lucky, and we worked pretty hard on that. And there were techniques that we had never used before, and we had to learn them, and so on. We had to prepare radioactive compounds. The basic idea was to get a compound that binds to the receptor, then bind it to the receptor. So we were able to identify a compound which chemically turned out to be completely different from the compound in the plant. The compound in the plant is based on what in the chemistry we call terpenes, and the compound that were isolated from the pig brain is something else entirely. It's based on a fatty acid, but they had the same type of activity. It is strange that a plant THC and anandamide, and we call the compound that we isolated anandamide, and anandamide had essentially the same activity. Could have been discovered years ago, but it wasn't. And other biochemical systems like dopamine and serotonin and so on have been investigated. There are thousands of papers on them. And then all of a sudden, there is a new major biochemical system of considerable importance. So something like 40 years ago, and that's why I'm trying to tell you something that was really, really at the beginning. I worked with a group in Brazil, in Sao Paulo, on epilepsy. We knew that cannabis is used as an anti-epileptic agent. And we and others found that cannabidiol is the major compound. Now that was interesting because cannabidiol does not have any side effect or has very few side effects. It does not cause the psychoactivity. A person that has epilepsy doesn't want the psychoactivity. He just doesn't want to have the attack. So we worked on mice and we found that, yes, cannabidiol is outstanding in mice. And then they got, our colleagues in Brazil got an okay from the Ministry of whatever to try it in humans. And they tried it in epileptic patients that nothing was helping them anymore. And they tried it on 15 patients. Half of them got the placebo, that to say only the solvent without cannabidiol, and the others got cannabidiol, about 200 milligrams per day. We had to prepare huge amounts of cannabidiol from the confiscated cannabis that we got from the police. But anyway, and they found that out of 7 patients, 4 had almost no attacks, and previously they had 1 or 2 attacks a day. 3 had very few attacks, and only 1 was not affected. And we published that, and I thought, well, here we have something new. There are a lot of epileptic patients that nothing is helping them anymore, and here we have something that maybe will help them. And I was disappointed to see that nothing happens. Clinicians didn't want to go into cannabis. They knew it's an illicit drug. They probably, even if they tried, it was difficult to get an okay from whatever ministry or was in their particular country. And so nothing happened for nearly 30 years. We published our paper 1980 in several countries. I think that in Canada, this extract, this compound, essentially 99% cannabidiol, is used as an anti-epileptic agent in children. Now, why did we have to wait 30 years? We could have helped, saved, if you wish, hundreds or maybe thousands of children. But working with a compound that has a background or like cannabis, illegal and so on, causes problems. But I'm delighted that here we have cannabidiol approved for a major disease. There we stand. So I gave you this an example, but of course we know today that both cannabidiol and THC can help with certain diseases. There we are.
The legalization of medical and recreational cannabis, because in 2018, Canada legalized the recreational cannabis. So what's your opinion on this? Just curiosity. And do you think that legalization can contribute to more intensive progress in medical research, or it's just purely a social aspect?
Well, it's essentially a social aspect, but whether cannabis should be legalized or not is really depends on the population of a certain country. If the population of a country thinks that this should be done, go ahead. If it doesn't, why go against it? And there are many countries, let's say in Eastern Europe. I don't think that in Russia it will it can be legalized. On the other hand, there are states in the US that it has been legalized. There are certain states, I believe that about half of the states in the US have legalized cannabis, both for medical and for recreational use. Now, the medical use, of course, should be legalized. It's ridiculous that here we have a possibility of helping people. So obviously it should be legalized, even if it is not legalized for recreational purposes. The medical, it should be legalized because we can help people and we can help quite a lot of people. So these are two different aspects, most definitely.
Also, more related to the doses of THC, what do you think about high THC and how most of the recreational strains have very high THC? And why do you think that some people are having adverse effects from this, like anxiety and distress from consuming high THC? What's your opinion about this for the recreational marketing?
Well, many years ago, the amount of THC, just about throughout the world, the amount of THC was relatively low. It was about 2%, 3%, something like that. But now that it has either been legalized or it's widely used, it has gone up. And in some places, it may be 10% or even more than that, 12%. And I've heard that some places it's even higher than that. Now, if we have, as an example, a young person who has never used cannabis previously, if he gets cannabis that has such a high level of THC, chances are that he will not only enjoy it, but actually it can cause an attack and he may end in the hospital and being treated. And this has happened many, many times, especially, as I said, in young people that have never used cannabis.
In our episodes, we often refer to the effect of entourage or entourage effect, especially when writing of the synergy of various cannabinoids, terpenes, and flavonoids in recreational cannabis. How correct you think and scientifically substantiated is this?
Well, we found, and it was, I mean, people kind of knew about it before. We found that the effect of THC-like compounds, or especially of compounds like the endogenous compounds, is enhanced or is changed by the constituents that are in the plant. Now, the plant contains a lot of cannabinoids, about 100 of them, most of them in very, very low amounts, but it also contains a lot of other compounds, which chemists known to chemists as terpenes and so on. And we found that actually compounds that do not have an activity by themselves change somewhat the activity of the effective compounds. Now, this is different from synergy. In synergy, we have a compound that acts one and the other one that acts one, and together they act not 1 + 1 = 2, but 1 + 1 = 3. Here we have sometimes compounds that don't act at all. So we have 1 and 0 is not 1, but 2. And we tested a few compounds under certain conditions. And yes, we found that some of the activities can be enhanced or changed by compounds that do not have activity by themselves. And we call this the entourage effect. Unfortunately, it has not been investigated thoroughly. We have done just 1 or 2 papers on the entourage effect. Not all the compounds do that. Some compounds seem to cause entourage effect, others do not. Some effects are changed by the entourage, others are not. So there are publications, excellent publications, incidentally, by some very good groups in the US that have shown that under certain, with certain compounds, we do not see the entourage. So we really have to know a little bit more about the entourage effect and know when, where, and how it acts.
Professor, we heard about a very interesting study in which you are participating with Dr. Linda Parker from our home state, Ontario, regarding addictions. Tell us a few words about it, because usually people associate cannabis with drug addiction and not addiction control.
Well, THC does cause addiction, not a strong addiction like heroin, but it does cause addiction. This is a fact that has been established. It's not a very potent addiction. If somebody is addicted to cannabis, THC, and wants to leave it, so he doesn't feel very happy for a few days, or maybe a week or 10 days, but he can get out of it. Done quite a bit of work. Most of it has been done in Canada, and she has done some outstanding work with the cannabinoids, and I suggest that you discuss with her or the effect she has seen. But most definitely, we can see that in nicotine, for example, nicotine causes addiction. Nicotine is, well, let's say people that smoke cigarettes damage themselves. And she has seen that cannabinoids can block the formation of addiction to nicotine, not to opiates. It turned out that a compound that our brain forms, not a very complicated compound, but structurally, chemically related to cannabinoids, can block this formation of addiction. And what was even more interesting is that this particular compound can block the effects of stopping the use of the addictive compounds. When somebody is addicted, whether it's to nicotine or whether it's to opiate, one gets into a very unpleasant state looking for the compound. The body looks for these compounds and they're not available. And so that's kind of a, let's say, state of or disease state, if you wish. And these compounds can block this effect. And they can block the effect not only of nicotine, but they can block the effect of opiates. Well, the compound we found in the brain was not very, the compound is not very stable. So we synthesized a compound and sent it to Canada to be tested. And it turned out to be a little bit better. So now she uses this synthetic compound to block the withdrawal effects of nicotine, the withdrawal effects of opiates, and so on.
I just have to ask this question because in 2009, I lost my mom because of cancer. And, you know, like there are lots of talks about like how THC can affect the cancer, and most of them are absolutely anecdotal, right? But can we say now that there is a reason to believe that the cannabinoids can help to treat cancer? Are there any studies about like extreme doses of THC? Because there are some people who are using just their own experience, like Rick Simpson, and he has a special concentrate, and he treats people with like high dosage of THC. But again, there is no studies under it. What do you know about cancer and THC?
Well, you say there are no studies. This is not correct. There are a lot of studies. Another word that you used is also correct. Help. You didn't say it eliminates the cancer or actually treats the cancer patient. It definitely affects the treated person. It can help with anti-cancer agents and make them more powerful or change their activity. It can help with some of the side effects due to the anti-cancer treatment. In many cases, the treatment of cancer is, it comes together with quite a lot of unpleasant effects. And many of these unpleasant effects can be affected by cannabinoids, but nobody has yet shown that the cannabinoid is really an anti-cancer agent. Maybe, just maybe, it will show better activity in some specific cancer, but at the moment, it is definitely not considered an anti-cancer agent as such. It, as you said, it helps, but it is not an anti-cancer agent. Hopefully, this will change, but at the moment, this is the situation.
So I understand that this question is not entirely your specialty, but why do you think research is progressing so slowly? Is it due to politics? Is it due to financing? And in your opinion, what can we do about this to kind of, to speed up the process?
Well, the preclinical work has gone ahead, relatively rapidly. The clinical work has not. The clinical work goes ahead very slowly. First of all, one needs, in just about every country, certainly in every modern country, one needs a lot of permits from Ministry A and Ministry B and so on. And these ministers are not very happy to do that. But probably the main reason why clinical work has not gone ahead is that the major companies have not been involved. Most of the drugs, essentially all the modern drugs that we have, come from companies. And companies are not very happy, at least the major companies are not very happy to work with compounds that have a background being illicit. I can't see a major company being very happy. Next day, one has a big something in the newspaper saying company so-and-so makes millions out of an illicit drug. The companies are not very happy with it. They try to stay away. So the big companies are not developing cannabinoids. maybe this will change. Maybe it is already changing. But so far, the big companies, most of them have stayed away.
What would you say to our viewers who would like to take the same career path as you?
Well, I believe that research is an outstanding way to spend your life in. You see, I'm a professor at the university. Now I'm retired, but I had to give lectures and worked with students, and I was delighted to work with students. And then I could do what I wanted, and I was paid for it.
That's beautiful.
That's the best.
There are not many things in life that you can do, and you're paid a salary, and you can go ahead and you can collaborate with outstanding colleagues in many countries, can meet these friends and discuss topics of sometimes major interest. You can start things that nobody will think they're worthwhile, but they may turn out to be worthwhile. So in my view, and of course, it's my view, that's not the view of many others. In my view, research is an excellent pathway in life.
Beautiful.
Absolutely,
Thank you so
yeah.
much. Just one little second, because
We have a show and tell kind of prepared for you.
just a little present from us. It's one of the artists. He's very well known artist, and he made this picture of you, and this picture apparently is pretty viral. It's like people doing T-shirts with it and stuff. So, and this is the original exactly from him. So if you don't mind, just give us the address where we can send the picture. We would be like really honored you to
Actually,
have.
I've seen this, but this picture, this drawing actually shows a few things. First of all, it shows the beginning, working with the plant itself. The green is the plant itself. Then we and many others moved into mechanism. And if you bring it up a bit, you'll see that there is something that's supposed to be a receptor. So we could move from the plant to the biochemistry, and there is this absolute this mechanism of action, and all this was done in about 30 or 40 years, a collaboration with many friends, at times together, at times separately, and this is something that I've enjoyed, and I'm glad that we have moved essentially from the beginning, from the plant to the biochemistry, to the clinical aspect, and hopefully to new drugs.
Yeah.
I have a personal question.
Yeah.
Yes.
You're not Canadian, I believe.
No, I mean, like, I'm Canadian, but I'm Russian-speaking Canadian.
I used to know Russian many years ago, but I forgot.
Oh, really?
Read Russian literature.
Your parents from Bulgaria, I guess.
I was born in Bulgaria.
You were born in Bulgaria.
And actually we came to Israel when I was 18 years old, 19 years old. So I studied Slavic literature and language and so on.
Do you have any collaborations with, like, because as you said, the topic of THC and cannabis in Eastern Europe is like super illegal, right? But did you have any collabs with people, with doctors from Eastern Europe?
A little bit. Most of my collaboration still is with friends and colleagues in Western Europe, in England, major, in the US, in Canada, in South America. I collaborated a little bit with a fellow out of all places, in Siberia.
Oh, wow.
And We even have a few papers together. They are colleagues. I haven't collaborated with them, but they are colleagues I know, and I realize that they do very good work in Poland and quite a lot in the Czech state. Well, the Czech state is kind of half Western, half Eastern, but not in Romania, Bulgaria, Russia, outside that of Siberia. That's the situation. For some strange reason, they are more strict, I believe, than the Western states.
That's true.
That is true, yeah.
That is true.
Again, Professor, thank you so much for taking the time out of your day to connect with us and to kind
You're
of...
welcome. And I will suggest that you try to show that the cannabinoids most certainly can become excellent drugs in several different directions. We didn't have time to talk about them, but it's quite possible that 10 years from today, we shall have a few cannabinoid drugs on the market.
Do you believe that cannabidiol is the most promising cannabinoid in the near future, or?
Oh, yes, but maybe derivatives of cannabidiol. You see, the companies don't like to use the natural product. The companies like to use derivatives. A natural product, a plant makes a product for itself. It doesn't care that much whether humans will like it or not. But we can take a natural product, make a change in the structure, and make it more suitable as a drug. And this is true for quite a lot of drugs that we have on the market today. They are natural products which have been slightly changed. The company can take a patent, and therefore it can develop it. And this is the way it works. Chances are that cannabinoids will be used in the same way, namely, we shall have natural cannabinoids which are slightly changed, whether it's cannabidiol, slightly changed, or cannabigerol, which is slightly changed. And chances are that we shall have drugs that are based on plant cannabinoids, but are slightly different. Or we can have compounds that are based on the endogenous compounds, but are slightly different. After all, the endogenous compounds they're not hormones, but they're natural products that do a lot of things in our body, in our brain. And by changing them a little bit, we can have, hopefully, major drugs.
Absolutely.
There we are.
Thank you so much.
Thank you so much, Professor. It's a pleasure.
And
Bye-bye.
if you don't mind, just Cornell will send you an email and just give us the most, like, the best address.
Yes.
So we can send you a picture from the artist. He was asking us a lot, so he wants you to have this picture.
Yes.
Thank you very much.
Thank you very much. It's an honor.
Thank you, Professor.
Bye-bye.
Thank you.
Bye.
Take care.